Dear students, today I am going to discuss mathematical relations which you come across in physics frequently. We can call them as mathematical tools. Physics is a quantitative subject. It deals with measurements. So in order to understand the interdependence of various physical quantities and to express them in the form of equations, the knowledge of basic mathematics is very much essential. So here I am going to take some mathematical relations. The first one, direct proportionality. At high school physics, you come across this statement in many cases. For example, according to Newton's second law, force is directly proportional to rate of change of momentum in the direction of force. So here you have this word direct proportionality. Similarly, while studying gas laws, you studied about Charles' law. That is, the volume of given mass of gas, it is directly proportional to absolute temperature. So you learned these type of statements at school level. So what do you mean by this direct proportionality? If two physical quantities are there, when do you say they are directly proportional? When I ask this question in a regular class, generally the students say that when one quantity increases, if the other quantity also increases, then they are said to be directly proportional. They say it like that. But it is not true. So direct proportionality means if one quantity increases, the other quantity would also increase by a constant factor, then only they are said to be directly proportional. For example, here I take two physical quantities. One is x, another one is y. X and y are two physical quantities. Physical quantity means anything which is measurable can be called as a physical quantity. For example, you can measure length, mass, time, temperature, volume, density. So like that, all the quantities which are measurable, they can be called as physical quantities. Here I have taken two arbitrary physical quantities, x and y. Say when x takes these values, when x is 1, y is 2. When x is 2, y is 3. When x is 3, y is 5. When x is 4, y is 9. When x is 5, y is 10. When this quantity is varying like this also varies this way. That means when one increases, the other one is also increasing. Then you can't say that these two are directly proportional. Because when x varies, y is not varying by a constant factor. Therefore, though one increases, the other one also increases, but not by a constant factor. These two are not said to be directly proportional. So we say these two are proportional if they are varying like this. When x is equal to 1, y is equal to 2. When x is equal to 2, y takes 4. When x is equal to 3, y becomes 6. When this is 4, this becomes 8. And this is 5, this becomes 10. Understand? So x increases, y also increases. See this 2, it can be written as 2 into 1. What is this 1? This is x. This 4, it can be written as 2 into 2. This 6, it can be written as 2 into 3. This 8, it can be written as 2 into 4. This 10, it can be written as 2 into 5. That means here these are all x values. So when x increases, y also increases by a constant factor which is equal to 2. So between two physical quantities, when the variation is like this, that means when one quantity increases, the other quantity also increase by a constant factor, then they are said to be directly proportional. So here this y, it can be equal to this constant k into x. So when x is proportional to y, this is the symbol for direct proportionality. This y can also be proportional to x. In such a case, whenever a proportionality is replaced by inequality, we use a proportionality constant like this. When two physical quantities are directly proportional, they can be equated by using a proportionality constant. It means that when x increases, y would also increase by this many number of times, k number of times. Understand? So when two physical quantities are directly proportional, the proportionality can be replaced by inequality by using this proportionality constant. Or otherwise, this y by x, this is equal to constant. See, when x is proportional to y, y will also be proportional to x. If I write x is equal to ky, then k becomes x by y. If I take y is equal to x, y is proportional to x, then y becomes equal to k times x. So y by x is equal to constant. So overall, this term should be a constant value. So you can also make out that if two physical quantities are directly proportional, then their ratio must be a constant. If two physical quantities are directly proportional, the ratio between these two physical quantities must be always a constant. And further, when two quantities are directly proportional like this, if you plot a graph between them, y versus x, what type of graph you would expect? Obviously, it must be a straight line. See, in this case, suppose these are the values of x and y. If I plot a graph, x is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, say 10. So 2, this is 4, this is 6, this is 8, 10. When x is equal to 1, y is equal to 2, you will get point here. When x is equal to 2, y is equal to 4. When x is equal to 3, it is 6. When this is 4, then this is 8. When this is 5, this is 10. So if I join these lines, what you get? A straight line like this. See, for every mathematical relation, you can have graphs. So for this direct proportionality, when two quantities are directly proportional, then the graph between them will be a straight line like this. Straight line with positive slope. Slope means inclination. By what angle this has been inclined with respect to x-axis, that is called slope. So this is called a straight line. See, this is a straight line, this is a straight line, this is also a straight line. So what type of straight line is this? Means this is a straight line with positive slope. So this inclination is called as slope. Say if I find the slope, what you are going to get, you check. See, this is 2, this is 4. This is one point where the coordinates are 1 and 2. This is another point where the coordinates are 2 and 4. You can find the slope of this straight line anywhere. So in a graph like this, whenever you want to find the slope, just you attach a right angle triangle to this straight line. You can attach this right angle triangle anywhere. So you can find the slope anywhere, the inclination will remain same. That means slope will remain same. So the slope is given by this angle theta, which is also called as tan theta, which is opposite side divided by the adjacent side BC. So what is this opposite side? From here to here it is 4 units. From here to here it is 2 units. So this is 4 minus 2. See, this is 4 units, this is 2 units. So AB becomes 4 minus 2. BC, this is 2 units and this is 1 unit. So it is 2 minus 1. So it is 2 by 1, which is 2. That means when you find the slope of this straight line, what you get? 2. 2 means this. For these values, this 2 means K. So you got the value of K. That means the value of proportionality constant. So you keep this in mind. When two physical quantities are directly proportional, the graph between them will be a straight line with positive slope, and the slope of that straight line would give you the value of proportionality constant. So whenever I say two physical quantities are directly proportional, all these things should come into your mind. You come across so many equations which are of this form. In the study of first year physics as well as second year physics, you come across so many mathematical relations of this form. For example, while studying this thermal properties of matter, you come across linear expansion. Say here there is a wire of length L1 at temperature T1. There is a wire of length L1 at temperature T1. Now this wire is heated to a temperature T2. So obviously this length will increase to L2, L1 to L2. So what is the increase in length? Delta L, which is L2 minus L1. This is the increase in length. This increase in length, it is found to be directly proportional to initial temperature, and also it is directly proportional to the initial temperature and also the temperature difference T2 minus T1. So therefore this L2 minus L1, it can be written as some proportionality constant alpha, initial length L1 and T2 minus T1. See, the increase in length, it is directly proportional to initial length and the temperature difference. That means more is the initial length, more will be the increase in length. More is the temperature difference, more will be the increase in length. So increase in length, it is proportional to these two factors. Therefore we write that L2 minus L1 is equal to some proportionality constant into L1 into T2 minus T1. So this L2 can be written as L2 can be written as L1 plus L1 alpha T2 minus T1. So therefore this L2 can be written as L1 into 1 plus alpha T2 minus T1. So this is the equation. If I take initial temperature to be 0 degrees Celsius, if I take T1 to be 0, if I take T1 is equal to 0 degrees Celsius, then in general this equation can be written as L is equal to L0 into 1 plus alpha T. See, when this term becomes 0, I write L2 as L, L1 as L0, T2 as T. Therefore, the same equation can also be written like this. So this is the general case and this is the specific case. So with increase of temperature, the length will increase. If I plot a graph of this L versus T, what type of graph do you expect? Here increase of length is proportional to temperature. This one delta L proportional to T2 minus T1. So if I plot a graph of this L versus T, what type of graph I would get? Obviously it must be a straight line, because this equation is of the form y is equal to mx plus c. See, this can be written as L is equal to L0 plus L0 alpha t. This is of the form y is equal to mx plus c. Therefore, if I plot a graph of this L versus T, if you understood all these things, it is well and good. If you could not follow these equations, just you remember that. L0 is the initial length at 0 degrees Celsius. L is the length at temperature T. Then the relation between these two is given by this equation. The relation between L and L0 T is given by this equation, where this term alpha it is called coefficient of linear expansion of material of the wire. It is the property of the material. So you just remember this relation, and this relation can be written like this. This is of this form. So this y is equal to mx plus c, it being equation of a straight line. When I plot a graph of this L versus T, I will get a straight line like this. So this is a straight line with positive slope. That means here this slope ABC, AB divided by BC, so this m stands for slope here. So this L0 alpha slope is given by, slope will give you L0 into alpha, coefficient of linear expansion of material of the wire. And this term here, this C is nothing but L0. L0 means length of the wire at 0 degree Celsius. So this value it is called y-intercept. So this intercept it is nothing but L0. Then how to find this alpha? Alpha is equal to slope by intercept. See, in the NEET examination, you will be given a graph like this. The length of a wire at different temperatures is plotted against the temperature in the given diagram. What is the coefficient of linear expansion of the wire? If the question is asked like this, since the relation between L and T is this one, and this equation is of this form, this M stands for slope and C stands for intercept. So this you take 2 points A and C, you construct a right angle triangle and you find the slope. That slope will give you L naught alpha, and this y-intercept will give you L naught. From that you can find the coefficient of linear expansion of the material of the wire. So from here onwards, this is a straight line. That means above L naught, length is proportional to temperature. That means more you increase the temperature, the length increases proportionately. So this is one of the examples for proportionality and also the equation of a straight line. You come across many relations like this. For example, in PUC second year, you learn that resistance of a material of a wire, electrical resistance of material of a conductor, it is given by RT is equal to R naught into 1 plus alpha T. So when you plot a graph of resistance versus temperature, you will get same type of graph. This alpha can be found by using the slope divided by intercept. So you come across many relations of this form in the study of PU1 and PU2 physics. So this is one mathematical relation which you come across frequently. The second thing is inverse proportionality. So here quantities are said to be inversely proportional when one quantity increases, the other decreases proportionately, that means by a constant factor. So here also I take two quantities x and y. When this physical quantity x takes the value 1, say let the y be 12. When this x increases to 2, y decreases to 6. When this increases to 3, this decreases to 4. When this increases to 4, this becomes 3. When this becomes 5, this decreases to 1.2, like that. So when one quantity increases, the other quantity decreases by constant factor. See, when two quantities are inversely proportional, they are represented like this. Y proportional to 1 by x, or y is inversely proportional to x. See, y is directly proportional to 1 by x or y is inversely proportional to x, both are one and the same. In case of direct proportionality, I told you that this can be written as y is equal to k into 1 by x. That means this x into y is equal to a constant. So when two quantities are inversely proportional, their product must be always a constant. That means when one quantity increases, the other quantity decreases such that their product always remains constant, then they are said to be inversely proportional. Understand? So when one quantity increases, the other quantity decreases such that their product will be a constant, then they are said to be inversely proportional. Again, you come across so many relations which are inversely proportional. For example, you might have studied about Boyle's law. Pressure of given mass of gas varies inversely with volume when the temperature remains constant. Pressure is inversely proportional to volume at constant temperature. So, P inversely proportional to V, we write PV is equal to a constant. So, at pressure P1, V1 is the volume. At pressure P2, V2 is the volume. So, P1, V1 is a constant and P2, V2 is also a constant. These two constants being same, we can write that P1, V1 is equal to P2, V2. While studying these gas laws in physics as well as in chemistry, we write equations like this. P is inversely proportional to V according to Boyle's law, therefore PV is a constant. At one particular pressure P1, V1 is the volume, so therefore P1, V1 is a constant. At another pressure P2, V2 is the volume, so P2, V2 is also a constant. Since this constant is same for a given gas, these two can be equated like this. P1, V1 is equal to P2, V2. So while solving numerical problems, you need to use these type of equations to get the solutions. And also, when two physical quantities are inversely proportional like this, if you plot a graph of them like this, you will get a curve like this. It won't be a perfect straight line. So you get a curve like this. So when physical quantities are inversely proportional, the graphical relation will be like this. The next one is exponential functions. Exponential functions. You come across equations like this. Y is one physical quantity, X is another physical quantity. The relation between Y and X is like this. Y is equal to e to the power of X. Then these functions are called exponential functions. In this exponential function, this e stands for a numerical value which is 2.718. E is exponential constant, its value is 2.718. So this being a constant, as x increases, e to the power of x increases, therefore the y also will increase. So as x increases, y increases exponentially. So here, for an exponential function, if you plot a graph of y versus x, it will be like this. That means the increase is quite sharp. So in general context also we use this term. When something increases rapidly, we say that it is exponential rise. And also sometimes you also come across the relations of this type. Y is equal to e to the power of minus x. So here This e to the power of minus x can be written as 1 divided by e to the power of x according to theory of indices. So when x increases, e to the power of x will increase, 1 divided by e to the power of x will decrease. That means as x increases, y decreases here. So if I plot a graph of y versus x, I will get this type of graph. For example, at a school level you studied about Rutherford's radioactive decay law, which is written like this: n is equal to n naught e to the power of minus lambda t. In this expression, this n naught is number of atoms in the radioactive sample, number of nuclei in the radioactive sample at t is equal to 0. Number of parent nuclei in the radioactive sample. After time t, the number of parent nuclei present, it is given by this equation. So this n naught is a constant, lambda is a decay constant, this t is time. As time increases, this e to the power of minus lambda t will decrease, so n decreases. So if I plot a graph of this n versus t, I will get this type of graph. So if I plot a graph of n versus t for this particular equation, this being undergoing exponential decay, the graph would be like this. So you come across these exponential functions in the study of physics. Another example is when a capacitor is charged, the charge on this capacitor, it is given by q is equal to q naught 1 minus e to the power of minus t divided by RC. You have an equation like this. Q naught is the maximum charge. R and C, this is the resistance of the circuit, C is the capacitance, and this is the time. So during the charging of capacitor, as the time increases, this Q will increase, because with increase of t, this term decreases. So 1 minus of that decreased term will increase. Therefore, if you plot a graph of this Q versus t, you will get this type of graph. See, understanding of mathematical equations and corresponding graphs is very much essential in physics. Understand? So most part of physics is nothing but mathematics only, but practical application. So you come across these equations from mathematical considerations. The corresponding graphs, you should imagine this being an exponential function. So the charge on the plates of the capacitor increases with respect to time accordingly. And also, in the study of physics, you come across solving equations, simultaneous equations. So when number of equations and number of unknown quantities are same, then you can solve them and you can find the unknown quantities. And also, you come across the solving of quadratic equations, particularly second order quadratic equation. ax square plus bx plus c is equal to 0. This is a second order quadratic equation. So what are the roots means? You know this relation minus b plus or minus root of b square minus 4ac divided by 2a. So if I consider one root, this will be minus 1 plus b square minus 4ac divided by 2a. Correspondingly, the other root will be this one. So if you know these roots x1, the sum of the roots b1 x1 plus x2 will be minus b by a, and the product of the roots x1 into x2 will be 4ac. So if this discriminant becomes 0, b square minus 4ac is 0, then the roots will become equal. So you should keep these things in mind while solving these quadratic equations. And also binomial expansion. Binomial means two terms. Here you have two terms like a plus b. So if I ask you what is a plus b whole square, you can give the answer immediately. Even if I ask you what is a plus b whole cube, you can get the answer. I can get the answer immediately. But when the power is extremely high, like a plus b whole to the power of n, then how to expand it? In such a case, we need to take this help of binomial expansion. So the power may be positive or negative, whatever may be the terms here, irrespective of all those things. If you remember this binomial expansion, a plus x whole to the power of n. So this is a to the power of n plus n into a to the power of n minus 1 x divided by 1 factorial plus n into n minus 1 a to the power of n minus 2 x square divided by 2 factorial. Like this, there will be n terms and the last term will be x to the power of n factorial. You are going to get these things in mathematics. PUC first year mathematics, you are having this binomial expansion. So in this expansion, this factorial, 1 factorial means 1, 2 factorial means 2 into 1, 3 factorial means 3 into 2 into 1, 4 factorial means 4 into 3 into 2 into 1, like that. N factorial means n into n minus 1 into n minus 2 into n minus 3 and so on. So this is the general expression for binomial expansion. Usually in this binomial expansion, if I take the values for x, a and x, the value of these terms decreases rapidly. So this is one term, second term, third term, fourth term and so on. These values of these terms decreases rapidly. That means the value of the first two terms will be very much high when compared to the value of other terms. So in any binomial expansion, we never take n terms like this. We take first 2 or 3 terms and neglect the other terms because their value is quite small compared to the first 2 terms. Understand? So whenever a binomial, whenever 2 terms rise to some arbitrary power, we use this binomial expansion. For example, in the study of gravitation, you come across this equation: acceleration due to gravity at a height h divided by acceleration due to gravity on the earth, on the surface of the earth. you get this equation r square divided by r plus h whole square. You get the equation like this. So if I rewrite this equation, it will be like this. R divided by r plus h whole square. If I divide the numerator and denominator, if I divide the numerator and denominator with r, it will be 1 divided by 1 plus h divided by r whole square. So I divide the numerator and denominator with capital R, so it becomes 1 divided by 1 plus h by r whole square. So I take this 1 plus h by r to the numerator, then what happens? It is 1 plus h by r whole to the power of minus 2. When the term in the denominator is brought to the numerator, the power will become negative, that's why it becomes minus 2. So this g dash, it is equal to g into 1 plus h by r whole to the power of minus 2. You know a plus b whole square, but this is a plus b whole to the power of minus 2. In such a case, how to expand this means we use this binomial expansion. So according to this binomial expansion, this a is equal to 1, this one, a is equal to 1 and x is equal to h by r. First a to the power of 1, that means it is 1. Next, this n means power is minus 2. N means power, so it is minus 2. And this x is there, that means h divided by 2r. And this is 1 power of minus 2 minus 1, it becomes 1 only. So therefore, this is the expression you will get for acceleration due to gravity at height. Here I have taken this term and this term, I neglected the other terms because their value is negligibly small compared to the first two terms. So like this, we need to use this expression, binomial expansion, when these type of powers are there. We take first two terms in the binomial expansion and neglect the others. That's why this equation reduces to this form. This is the expression for acceleration due to gravity at a height h from the surface of the earth. So, like this you come across a lot of algebra in the study of physics, and in the next class I will take some trigonometry, geometry and also some part of calculus.